The Coanda effect is a hydrodynamic phenomenon indicating and describing the tendency of fluid jets to adhere to or become attracted to nearby convex surfaces, deviating from a straight path of trajectory. The heart has intracardiac surfaces such as the mitral leaflets and the left atrial wall, as well as fluid jets which act adjacent to these surfaces. This makes the heart a possible location or site for the observation of the Coanda effect. The unique hydrodynamics associated with surface adherent jets in the heart and the qualitative measure of valvular disease severity carried out in Doppler echocardiography, among other features, led to the decision to model and analyze the Coanda effect in vitro to evaluate the influence of an adjacent surface on both regurgitant jet size and Doppler color pixel encoding. The model consisted of a non-compliant receiving chamber, a liquid suspension, smooth convex and straight aluminum surfaces, and a continuous flow pump connected to an inflow orifice and unrestricted flow outflow orifice to make a closed circuit. 4 conditions and a closed valve were set up and analyzed. Condition 1. A straight surface offset 4 mm to the side of the inflow orifice. Condition 2. A smoothly curved surface convex to the jet and offset 4 mm away. Condition 3. A straight surface placed adjacent to the origin of the jet. Condition 4. A smoothly curved surface also adjacent to the origin of the jet. A control condition without the surface, free jet, was used as the 5th condition. Color Doppler echocardiography has become an important and widely used diagnostic technique for definition of intracardiac blood flow patterns, especially in valvular heart disease. To analyze the Coanda effect in the heart, Doppler flow mapping was utilized in the in vitro study. For 10 flow rates, the corresponding jet areas, correlation coefficients, linear regression relations, and ANOVA and t-test results for each experimental condition were illustrated. The control condition had the largest jet area for each flow rate and the highest slope for the relation between jet area and flow rate. The linear regression relations between jet area and flow rate for conditions 2 and 4, curved surface, had higher slopes than for conditions 1 and 3, straight surface. The control flow jet area was larger than the jet area of each surface condition at each flow rate. Conditions 3 and 4 showed jets with smaller jet areas for the same flow rates than the corresponding conditions 1 and 2. Observations on color encoding demonstrated that the surface jets as a whole had more evidence of velocity variation and variance encoding. Although for decades it was known that jets occur in the heart during abnormal conditions, only recently strong approaches were made to studying relations between such flows and cardiac pathologies. In this experiment, it was shown that the Coanda effect may influence jet size and color encoding in color Doppler imaging. Jets that flow with an adjacent surface had smaller jet areas, more variance, and reverse flow pixels as opposed to free jets. Jet size was also influenced by the distance between the surface and the inflow orifice. Finally, greater reverse flow and greater disorganization of flow velocities was observed along the surface. Notably, the study had the following limitations. 1. High flow rates were not studied due to the limited range of the imaging sector. 2. The jet stream is spatially 3-dimensional, but only one plane was measured. 3. And lastly, concave surfaces were not used to compare differences among jet area measurements. For an eccentric regurgitant jet close to the left atrial wall or the ventricular septum, the jet will almost always adhere to the wall. This may cause jet stream flattening, making the jet appear smaller, with consequent underestimation of the measured severity of valvular regurgitation in color flow mapping. For further study, it is believed that an approach to the transvalvular regurgitant flow quantitation, based on a study of a more organized and laminar zone, may be a better approach to quantitation of color flow Doppler than attempting to quantitate the disorganized flow areas within the receiving chamber.